All right, 5.2, we're talking about bisectors of triangles today, and we're going to be talking specifically about perpendicular bisectors as well as angle bisectors of a triangle, and then we're going to apply both of those properties and into word problems at the end. So we've already bisected, or we've already constructed angle bisectors. You guys are professional angle bisectorers, and I don't know if we've mastered perpendicular bisectors yet, but we will eventually. And we're talking specifically about those two things in a triangle. So remember, a perpendicular bisector goes from one point, and you're going to make a perpendicular means meets at 90 degrees, and bisector means cut in half or meet at the midpoint, right? So perpendicular bisector would look, let's see, if I wanted to find out what the midpoint is, it looks like right here, but it also has to meet, it also has to be 90 degrees. So this would be an example of a perpendicular bisector of this line, and you would do it 3 more times. And we're going to see what happens to that. Angle bisector, you're not talking about lines, you're talking about angles. So angle bisector, if you take one angle in a triangle and you cut it into 2 congruent pieces, so those are my tick marks to show that those 2 are congruent to each other. Something special is going to happen with those. And some vocab that you need to know is when 3 or more lines intersect, in one point, those lines are said to be concurrent. So it's a fancy schmancy word for saying intersect. They intersect. And the point of concurrency is that point where they all intersect. So that's when we're talking about 3 or more lines. And since we're talking about triangles and they have 3 sides, these angle bisectors might all be intersecting, and the perpendicular bisectors might all be intersecting. So they'll be concurrent, and we'll have a point of concurrency. Okay, so the first thing we're going to talk about is in-center theorem, and that applies with angle bisectors. Okay, so if you imagine we had out our compasses and you guys did all those constructions, so this is the angle bisector of this angle, and I believe you guys did this already. Okay, so there's that one. And then let's say I did it to another angle. I did the construction, I did my arc marks, right? And then I found out where that angle bisector is. There it is. Sweet. So this one's right there. And then I did a third time for that third angle. Again, I did my constructions with my compass. And so bam, there's my third angle bisector. Well, what happens is they are going to all intersect. So they are concurrent. These lines, these angle bisectors are concurrent. Sorry, I didn't put enough tick marks. These ones have 3 tick marks because those angles are congruent. These black lines have 2 tick marks, angle marks, because these 2 angles are congruent. And this red angle has 1 tick mark because these 2 angles are congruent. So when the red, the black, and the blue line intersect, they're concurrent. This point of concurrency is called the incenter. So again, the incenter is made from angle bisectors, and that's important. The reason why that's important, I'm going to erase some of these lines, is because once we have that incenter, something special happens in that triangle. What happens is, again, this is the incenter. What happens is, if you took this point, this incenter, and let's say you wanted to find the shortest distance to this side. The shortest distance, again, is a perpendicular line. So bam, let's say that's a 90-degree angle. Okay, and then let's say I did it to this side too. Found a shortest distance as a perpendicular line. And then I did the same thing on this one. So I found the shortest distance, perpendicular line. I know it doesn't look like it from my picture, but these are going to be congruent to each other. So the incenter is made from angle bisectors, and important, the distance to the sides are always congruent, and that's why the incenter is important. So the incenter theorem basically says that. It says if we have 3 angle bisectors in a triangle that intersect, which they always do, okay, then that point, the incenter, is equal distance from the sides of the triangle. If I was going to draw that, if I wanted to draw pictures on my cheat sheet, because this should go on your cheat sheet, then I would say if I have a triangle and I have angle bisectors. So for me, I would go like this. And so that shows me that they're angle bisectors. Then that incenter is going to be uh, it's going to be equal distance. So that's why I'm going to put my tick marks to all the three sides of the triangle. So that's how I would draw it on my cheat sheet because I'm a visual person. Okay, so the cool thing about the incenter, the reason why it's called the incenter is because if we talk about the three different types of triangles, an acute triangle, an obtuse triangle with one obtuse angle, and a right triangle with one right angle, the incenter is always going to be inside the circle, hence incenter. Okay, so we have the incenter. We know what it is. We know why it's so special because it's congruent to all the sides. Now we're going to apply it. So there's two types of questions I can ask you guys. First of all, this is important. It says, notice there's no angle tick marks, right? So we have to read the question. It says MP and LP are angle bisectors. Whenever you see that word, angle bisectors, you're going to immediately think, aha, incenter. Therefore, they are congruent. The incenter is congruent to the sides. Okay, so we have MP is an angle bisector, so I can put tick marks on there. And I have LP is an angle bisector, so I'm going to put tick marks on that too. This is something that we can conclude based on this information. And it says find the distance from P, point P. So this, since we know P is the incenter, to MN. So MN is this side right here. So I want to know what's the shortest distance. When they say what's the distance, then we want the shortest distance because we're lazy. That's what we want. So this is what we're looking for. What is this? Well, in this picture, and I could give you a much more complicated picture, let's see what we're talking about. P is the incenter. Does it go to any of the other sides of the triangle? We want to figure out what it is when it goes to MN. Did we know about what it is when it gets to LN? No. This does not count, and it also doesn't give us a distance. From here to ML, this is a perpendicular line, and it's 5. So that means that this one is also going to be 5. And that means if I wanted to figure out, even though it didn't ask us, if we wanted to know what the distance from P to line LN is, that would also be 5. Okay, so that's one question, and again, I can make this picture a lot more complicated. That was kind of an easy question since 5 is the only side length I give you. The second type of question, so this is one type of question. The second type of question I can give you is, again, same thing. It says MP and LP are angle bisectors, so again, we're going to conclude that this is the incenter, which means it's congruent to the sides. But instead of finding the distance, this time I want you to find an angle. So that's how this question is a little bit different. Okay, so we still have all of our, the rest of this is the same, right? We still know this is the incenter. We still know that these are angle bisectors, so that those angles are going to be congruent. Now we can use that to our benefit, because if you look at this whole, there's lots of ways you guys can do this, really, honestly. Angle PMN. PMN is this one right here, right? This is how I approach this problem. I look at the whole triangle, okay? And I know that all the angles have to add up to be 180 degrees. So I already know that this angle is 20. Sweet. I know that they've got to equal up to 180 degrees. Now, I don't know everything about this angle, but I do know that this angle is 50, and these are angle bisectors, so that means that this angle is 50. So this whole angle of the triangle is now 100. And I don't know what this third angle is. And I know that this is part of it, right? So what I'm going to do is I'm going to add that up, and that's 120 degrees. So far we know this angle is 20, we know this angle is 100, so that's 120 degrees. Then I'm going to subtract that from 180, and that means that this whole entire angle has to equal 60 degrees. But that's not my final answer, because angle PMN, this part right here, is half of 60 degrees. So my final thing that I have to do is divide it by 2, and then I know now that my final answer is that this is 30 degrees. And if you wanted to check your answer, okay, so this is 30, this is 30, this is 50, this is 50, this is 20. Add them all up and see if they equal to be 180 degrees. And I like these questions because you really have to think of it like a puzzle, and that's kind of fun. Okay, so that's the incenter. I'm going to talk a little bit faster. The second thing we want to talk about is the circumcenter theorem. The circumcenter theorem is not derived from angle bisectors, but from perpendicular bisectors. So again, perpendicular means they meet at 90 degrees, and bisector means it's going to cut it into two congruent pieces. So for example, if I wanted to find the perpendicular bisector here, I'd say, okay, this is the midpoint, and it meets at 90-degree angle. Sweet. And I do the same thing over here. Okay, let's see, this one, the midpoint of this line would be here. So I'm going to put my tick mark so you know, and then there's 90 degrees right there. Sweet. And you do the same thing for the third side, and guess what? They're also going to be concurrent. These lines are going to be concurrent. So here's the midpoint. So this side is congruent to this side, and it meets at a right angle. So they're concurrent as well. They all intersect. This point is called the circumcenter. So where the perpendicular bisectors intersect, that's called the circumcenter. And there's something special that happens with the circumcenter. It says if three perpendicular bisectors of a triangle intersect, then that point, the circumcenter, is equidistant, equal distance to the vertices of the triangle. And when I say vertices of the triangle, I mean these things right here. So let me erase some of this stuff. Again, they're made by perpendicular bisectors. Okay, so that's important. And it's going to be equal distance to the vertices. That's really important. So I'm sorry, I think the circumcenter was here, right? So I'll call it CC. Okay, so that means from the circumcenter to this vertex, and to this vertex, and to this vertex, they're going to be congruent. I'm sorry, I need to erase this. Okay, so if I was going to write this theorem on my cheat sheet, because I'm a picture person, what I would say is if I had perpendicular bisectors, and I would show that they're perpendicular bisectors. So I would put my tick marks, and I'd put my right angle. And I do that for all three sides, just like I did previously. 1, 2, 3, 1, 2, 3, and that meets at a right angle. So if I have perpendicular bisectors, that means then that point, that circumcenter, is going to be equal distance to the vertices, to the angles basically. Now I know that doesn't look like it, but trust me, it works. The reason why it's not called an incenter, but it's called circumcenter, one of the reasons, is because unlike the incenter, the circumcenter can be in different spots. So for example, if you have an acute triangle, it will always be inside the triangle. If you have an obtuse triangle, it will be outside the triangle. And if you have a right triangle, it will be on the hypotenuse. So that's important. There are three types of questions that I can give you with the circumcenter. All right, the first one, it says, notice there's no perpendicular marks, there's no tick marks, so we have to read the question. It says line segment K, Z, ZL, and ZM, and I apologize that I don't have my markings, are the perpendicular bisectors. So whenever you see that word, perpendicular bisectors, you're going to automatically think, sweet, that's the circumcenter. Aha, so Z, this point where that point of concurrency where they all intersect, this is the circumcenter. And that means, therefore, it will be congruent to the angles or the vertices. Okay, so this one will be congruent to this angle, will be congruent to this angle. Sweet. And I know that they're perpendicular bisectors. So this is all the stuff, perpendicular. Okay, I got my perpendicular. What else can I conclude from if they're perpendicular bisectors? Well, I know that K is going to be a midpoint. So this side is going to be congruent to this side. And I can do that with all the sides. So the three different questions I can ask you, the easiest question is find HZ. Okay, well that's from the circumcenter to an angle. So we already said that those three have to be congruent to each other. I don't know anything about this one. I do know that this one's 19.9. So that means this one's 19.9 and this one is 19.9. So that's easy. The first thing I can ask you for is actually for the line that's from the circumcenter. I'll call it CC for shortcut. CC to the angle. That's one type of question I can ask you. The other type of question I can ask you is find GK. Find the side. How long is GK? So let's look at a picture. GK is a side of the triangle. Okay, so another type of questions I can ask you is the side of a triangle. Well, we know that they're perpendicular bisectors. So bisector means that, again, K is the midpoint. So that means that this piece is going to be congruent to this piece. So since this side is 18.6, this side has to be 18.6. Okay, so far they're pretty easy. You're either deciding is it from the circumcenter to the angle, or am I talking about the side of a triangle? Those are the easy questions. The hardest type of question I can give you is find the side length of KZ. KZ is neither of those things. KZ is define the perpendicular line. And I don't want you to get this confused with an angle with the incenter. This angle, this perpendicular line is not congruent to this perpendicular line, is not congruent to this perpendicular line, because it's not, this is not the incenter, it's a circumcenter. Okay, so what I can do then, I'm going to scroll up for just a little bit. I'm going to erase some of this stuff. What I can do is, let's see, KZ is this line right here. So this is the line we want to talk about. Okay, there's different ways you guys can approach this problem. I'm going to look at this part of the triangle. If you wanted to look at this bottom triangle, that would be fine. But again, we want to figure out what this one is. We don't know. We do know that this side is, oops, sorry. I was sitting stationary for too long. And my sensors turned off. Okay, thank you. So this side is 18.6. We also figured out up here that HZ, remember, all these are congruent to each other. So we know that this side is 19.9. We also know that this is perpendicular. So right here, this yellow one is a right triangle. So what you have to do, what we know we can do, is Pythagorean's theorem. A squared plus b squared equals c squared. In this case, since the 19.9 is across from the 90 degrees, that's your hypotenuse. And it doesn't really matter which one's A and B, so I'm going to say that side KZ squared, if you want to put X, that's fine, plus 18.6 squared is going to equal 19.9 squared. So again, if you want to do A squared or X squared plus 18.6 squared equals 19.9 squared. So go ahead and finish this problem. And that's how you're going to use it. So if I wanted you to find the perpendicular line, you need to do Pythagorean's theorem. And I know I went over a lot. You guys are amazing. Right now, what I need you to do is open up your books to page 311. If you want to get full points for this the longest video you've ever seen so far in geometry, you're going to open up to page 311 and you're going to do problems 3, 4, 9, and 10. And tomorrow in class, we're going to talk about how we can apply these to word problems in the real world. Yay, real world. All right, the fun fact of the video, because of course I wouldn't want you to miss that. Fun fact of the video is, let's see. Fun fact of the video is, oh yeah, tarantula can live for more than 2 years without eating a single thing. That is just one healthy diet. All right, you guys are rock stars. Thank you so much.